Welcome to the distance learning program on cloud computing by Innobus. In this chapter, we'll be covering topics of how to build the cloud networks. And we'll be looking at the following topics in building the cloud network: designing and implementing data center based cloud, industry and international standards for cloud, communication requirements for cloud implementation, private and public internet connection to the cloud, routing to the data center, switching between the data center parts, bandwidth of the data center cloud, security of the data center based cloud, storage options for the cloud computing deployed over data center. Let's see what are the designing and implementing parts in a data center based cloud. Before designing and implementing a data center based cloud, we should look at what are the different types of cloud. There are 5 major types of data center based clouds. The first one is transactional protection data center networks. These types are used for financial transactions. Here the latency results in gain or loss. It's required to have a high computing capabilities. The financial institutions like banks implement their business application in this type of networks where the latency considered to be 0, as it results in gain or loss of business. Another type is content and hosting service protection data center. Here the data center must support to the changing workload requirements. And how it works is like that. They are based on an infrastructure as a service cloud. They are used for normal content hosting or web page hosting services. Another type is high performance computer protection data center network. These are driven by the requirement of scientific innovations in the field of such as nanotechnology, biotechnology, genetics, and seismic modeling. Another type is enterprise IT data centers. As the name indicates, they are used by the enterprise clients for running customer resource management software like CRMs and enterprise resource planning systems like ERP, etc. And another type is small and medium business data centers. These data centers are basically used by small or medium businesses for running their applications. And these cloud networks needs to have the features like scalability and security. These are the major concerns in these types, and they need to be cost effective as well. And after looking at the types, let's go ahead and take a look at what are the design considerations while designing a data center based cloud. There are 4 major design considerations. First one is simplifying. Simplify, it means reducing the networking elements required to achieve the particular design, by which reducing the capital expenses and operational costs. Another one is sharing. As the name indicates, it means intelligently and dynamically partitioning the infrastructure to support diverse application, user groups, and interconnecting large pool of resources with maximum uptime or agility. Another one design consideration is security or secure. The cloud that we design needs to be a robust and multi-directional approach that enhances and extends the traditional perimeter defenses. Another design consideration is automate. How do we automate our data center based cloud? That's what comes under the automation. And that means the ability of the data center to capture the key steps involved in performing management, operation, and application tasks, and also embedding the task execution in a software that adds intelligence to overall cloud operation. The major or the usual task that we perform on a cloud needs to be automated, and these needs to be considered while designing our data center based cloud. Now let's go ahead and take a look at the industry and international standards for cloud. While designing or implementing a cloud, we need to know what are the standards that we need to remember, or that we need to work it out while designing our cloud infrastructure. The first standard would be Distributed Management Task Force, which is known as DMTF, and the product of DMTF is known as Open Virtualization Format, and it is based on how the virtualization needs to be done, the format, the specification. All these standards are considered under the DMTF standard. And another one is Cloud Management Working Group, CMWG, which introduced Cloud Infrastructure Management Interfaces, CIMI. And the Cloud Infrastructure Management Interface defines a logical model for resource management within the infrastructure as a service domain. Meanwhile, the CMWG, the Cloud Management Working Group, is developing a set of prospective specification that can deliver the architectural semantics as well as implementation details to achieve the interoperability management of clouds between service requester and provider. The Cloud Management Working Group are working on, or they are designing this standard, or they're developing this standard to have a clear interoperability management between the requester, who is the end user, and the provider, who is the cloud service provider. And the standard is by European Telecommunication Standards Institute, ETSI, and it has particular interest in interoperability solutions, emphasizing on infrastructure as a service. They're also known as TC Grid, otherwise TC Cloud, and the National Institute of Standards and Technology comes under the ETSI, and MIST also has a standard which is known as SAJAAC, which stands for Standard Acceleration to Jumpstart Adoption of Cloud Computing. And it has three components, which is, first one is NIST Inserts, which identifies and validates the specifications using use cases in cloud computing. Another one, NIST Receives and Coordinates. It receives and coordinates the prioritization of specifications and validates using these use cases. Another standard is NIST Identifies. It identifies the cloud standards. Let's take a look at what is other standards. For another one would be Open Grid Forum. It is a standard development organization in GRID, otherwise cloud related forms of distributed computing. They work on mainly on distributed computing, otherwise another name, cloud. An Open Cloud Computing Interface Working Group, OCCI Working Group, is a part of Open Grid Forum. And OCCI is a set of general purpose specifications for cloud-based interactions with the resources in a way that is explicitly vendor independent, extendable to solve the broad variety of problems in cloud computing. OCCI specifications is a set of it's a set that is being designed, or we can say it's a product of Open Grid Forum, and it has three parts, which is OCCI core spec, infrastructure spec, and HTTP rendering spec. The core spec indicates how exactly the core of the cloud needs to be designed, or what are the mandatory stuff that the code needs to be considered, and infrastructure spec, how the infrastructure needs to be designed, and HTTP rendering specs says how the HTTP services are being rendered from a cloud infrastructure. And the standard is Object Management Group, OMG, and this focus always on modeling the deployment and application services on a cloud for portability and interoperability, and also reuse. Another standard is Open Cloud Consortium, OCC, and it supports the development of standards for cloud computing frameworks for interoperability between the clouds. It enables, or it is used for standards which needs to be maintained while the interoperability comes between two different infrastructure or cloud. It also develops benchmarks for cloud, and mainly OCC, they focus on large data clouds. And let's see what are the other standards. Another one is Organization for Advancement of Structured Information Standards, also known as OASIS. This drives the development of open standards for global information society. And OASIS has 3 committees, and the first committee is OASIS Identity in the Cloud. TC stands for Technical Cloud. This committee works to address the serious security challenges proposed by the identity management in cloud computing. And the second one, OASIS Systems Automation Framework, which is another committee of OASIS, and what it does is it penetrates the separation between the consumer-based business requirements and provider-supplied IT responses. And third committee is Topology and Orchestration Specification for Cloud Application, TOSCA, and this is to enhance the portability of cloud applications and the IT services. And another standard is Storage Network Industry Association, SNIA. They got a technical group which is SNIA Technical Working Group, TWG, and it acts as a primary entity to identify system standards for cloud storage. It also produces a comprehensive set of specifications and drives the consistency of interface standards and messages across the various cloud storage related efforts. Now let's go ahead and check what are the communication requirements for cloud implementation. When it comes to communication of a cloud that we are designing or we are implementing, there are 2 types of communication, which is from the private internet and which is from the public internet. As the name indicates, the public and private internet, which is based on the communication flow, which could be inside or outside of the cloud. And the public internet, in designing and physical implementation of cloud infrastructure, as the public internet comes from outside of the cloud. For example, the communication through port 80 could be considered as a public internet request, and the communication from any other services or a system call from an inside component from the same data center could be considered as a private internet request. And these private internet requests between the resources within the infrastructure should be more secure and widely firewall filtered. And let's see what are the other features like data or packet routing to the data center. Okay, as we see, there's a figure which indicates how the communication that goes from the end user compute environment to the data center. These designs are called as inverse U communication, and the compute or the request from the compute goes directly to the switch, which comes in the cloud for security, which could be layer 2 or layer 3 request, and based on the request type they are being transferred from one to another. And it could be a processor based call or it could be a memory based call. These requests are being handled by the switches, manageable switches, at the same time using manageable routers or routing networks. And the routing, the communication to the data center cloud includes, it includes forwarding and handling the request to the data center. At the same time, it's multi-directional. To and from the data center is being transferred to or through these devices, and it includes different layer of communication with security at different layers. And now let's take a look at the switching within the data center. Okay. In the data center, we use manageable switches to manage these communication, and the major technologies that we use in a data center switching are VLAN, virtual LANs, and security zones. And another one is MPLS, which is known as multi-protocol label switching. MPLS is a packet forwarding technology that is capable of carrying L3 protocols and tunneling L3 packets. Why we use this L3? Because to make sure the data or the packet transferred between to and fro the cloud are secured. As the figure indicates, we got a core, and this hardware is being given to two virtual machines, we can say two data centers, and it has got different series of servers. At the same time, it has got VLANs, where the VLANs has different user groups, and based on the user group privilege of a user, these traffic are being monitored and handled. Now let's see what is another communication requirement for cloud implementation, which is bandwidth. We know that in the cloud infrastructure, every bit that comes in and out and goes out of the cloud are counted, since the end user is getting billed for the bandwidth that he or she uses. Okay, and the feature of elastic bandwidth is being implemented in the cloud implementation, since it is hard to predict how much bandwidth would be required by the end user. We use the technology of elastic bandwidth. That means the bandwidth can be increased or decreased based on the traffic, and it has the network or the cloud network has a feature of a rapid growth. It uses super channels, and the fibers should be scalable to meet the growing traffics. As we said before, the traffic could not be expected, and there should not be a limit for the traffic, so these bandwidths needs to be monitored. At the same time, these bandwidths can increase at any point of time, at the same time can decrease, so these needs to be elastic bandwidth. Another point is milliseconds matter. As we know, the cloud infrastructure is being used by small and medium business organizations to run their web application. Otherwise, a financial institution like banks are using it for running their web application, where the user should get better user experience, and the milliseconds, the operations or the requests handled by the in a milliseconds are pretty much large, and these requests should be handled in a well manner, and the latency should be 0 for a better user experience. And the bandwidth should be designed to meet the service request without any latency, and it provides, as we know, a better user experience. And since there is billing for the bandwidth by most of the cloud infrastructure providers, these bandwidths needs to be monitored as well. Let's see what are the security requirements for cloud implementation. We can divide the security into two different categories. First one is physical security, in which we have the security for the data center, in which otherwise the building in which the data center is running. At the same time, the perimeter of the data center should be secured. We should implement the features like CCTV and other monitoring tools for the physical security of the data center. And in the second category, logical security, it comes to firewalls that we use to secure our networks. And as usual, the normal or the unused ports on the server should be closed, and we should restrict access to the protocol, access by protocol, like for example HTTP or SSH. These things needs to be given to the end user. Meanwhile, other ports should be closed, and the data to and from the data center should be encrypted, and which also helps in preventing many type of hacking or prevent attacks to our data center. And also the single sign-on or the implemented of single sign-on and identity access management would be a plus while designing our storage security for the cloud. And on the figure we can see that what are the different security or what are the different things that comes under the security framework. Okay, the people and the identity. As we said before, the identity access management or single sign-on needs to be implemented, and the data and information, this needs to be encrypted. The data that comes out and goes out of the cloud infrastructure should be encrypted, where the many type of attacks can be prevented. And the application and the process, these are needs to be running on a environment in which none other than the required ports are opened. And the network and the server and the endpoint, these things comes under the virtual LANs that we use or the firewall that we use for making our cloud secure. And the physical infrastructure, as we said before, the building in which the cloud is running should be secured otherwise it should be secured by all means, by using perimeter defense, CCTV, etc. Now let's see what are the other communication requirements under the cloud implementation, where we have storage options. Okay, in storage options, first we have one major type of storage, which is network attached storage, otherwise NAS. And as the figure indicates, we know that in network attached storage, the storage is attached to the network, and it is being shared over a network using the network that we use. It's based on the type of network that we use there, and it's always better than the storage area attached network or storage area networks, and it's cost effective. And the new form of network attached storage is scale out network attached storage, which is being implemented by most of the new cloud infrastructure providers. Another type is storage attached network. The storage attached networks are we can call it as a high-speed special purpose networks that interconnect different kinds of data storage devices, which associates data servers on behalf of a large network of users. It gives high speed. Also, it supports the features like disk mirroring, where the data redundancy can be designed well. Archiving and retrieval of the data is pretty much easy with storage area network, and the data migration from one SAN to another is a pretty simple task, otherwise an easier task to perform. And there are advantages and disadvantages for SAN as well. Since it has high speed, because it is directly linked, which is an advantage, which results in high speed, and it is limitless. We can go ahead and attach the storage to the SAN, and there is no physical limit for attaching the size. And the disadvantages is that it is highly expensive while compared to network area storage. Let's see what is another storage option, which is known as cache, which is content addressable storage. How it works is that it uses a hashing algorithm. It's also known as cloud attached storage, content addressable storage, and content address storage. Since it's using the hashing algorithm, it gives each and every object a unique identifier by which it calls these data. And it is the backbone of content delivery networks. And the advantages and disadvantages are it's an improved form. It serves the data much faster than any other storage options, and usually we use it only for static contents. And the disadvantage would be, since we use it only for the static contents, the dynamic contents could not be implemented in the content addressable storage method. And also it's always preferred or recommended to have a less or no update to these contents in the cache. Let's see what are the redundancy options we have in designing a cloud, otherwise while implementing a cloud. We can use RAID. At the same time, we can use rsync. As we know, a RAID is a kind of a redundancy technique that is being used across many different data centers and cloud providers, where we can go ahead and take the backup of our data in another disk. In RAID 0, we know that it's just a copy of one. It writes the IO. The IO operations are being happening on both of the disk, as the figure indicates, disk 1 and disk 0. The IO operations are being happening at the same time in the real time on both. And by using other RAID levels like RAID 1 and RAID 5, RAID 10, RAID 50, all these can be used for redundancy techniques in cloud implementation, and the rsync can be used for data backup technologies or redundancy techniques. And what are the backup and recovery solutions that we can implement while designing our cloud? Are we can use the combination of storage technology, as we discussed before. We can use NAS, SAN, and cache. All these can be used in combination to our data center based cloud. And we can also use the backup technique of snapshot, where the end user can go ahead and take a snapshot of his or her virtual machine server, which can be used later in case of any downtime or hardware or OS failure. And another point for backup and recovery solutions would be multi-zone availability. By providing the multi-zone availability, the end user can always have a copy of his or her web application, which can be used in case of any recovery options. Thank you.